Alright, so 5.3 gets into what we call a perfectly competitive factor market, which is also called a resource market, or more specifically, the labor market, because that's the easiest way to study all this. So we have two different markets. We have perfect competition in a labor market, just like we talked about perfect competition in the product market. But instead of having one price, when we had that Mr. Dart curve, now you're going to have one wage, and that's going to be your MRC. So every worker is going to get paid the same amount. And then we have monopsony, which is a monopoly in a labor market, which we'll talk about tomorrow. We won't get to it today. But perfect competition in a labor market. So you've got tons of these small firms all hiring what we essentially call identical workers. So like product markets, it was a bunch of small firms producing identical products. Now we're all hiring workers that are all even to each other. There's no difference in their productivity. So no one firm is large enough to manipulate the market, and so they don't have, no one particular firm can influence the market like a monopoly could. So we assume workers have identical skills, wages constants. We refer to it as a wage-taking firm, just like we talked about a price-taking firm, because they're going to accept whatever that market equilibrium wage is. So it should tell you we're about to get into side-by-side graphs again. So you'll have the market graph for supply and demand of labor, and then you will have the firm, which will have not cost curves, but essentially wage curves. But anyways, market on the left. So we can see equilibrium wage of $10, equilibrium quantity of 5,000 workers. Remember, the x-axis is now the quantity of labor, which is just the number of people in that market.
What was the question mark for?
So on the right, we're going to have our MRC and MRP curves.
But we don't know what that is.
Well, we're going to run back through MRC and MRP, and then we'll put the curves up there. So, marginal resource cost is just the wage we have to pay the workers. So yesterday when we talked about the landscaping example and every worker got $100 a day, that was the MRC. But break it down, marginal, add one and look for the change. Resource, well in this case labor is our resource. What is the cost? So what is the cost of adding one more unit of labor? All it is the wage you have to pay the worker. Marginal revenue product measures how much additional revenue that one worker generates for the firm. And so it's a measure of productivity, but it's all marginal analysis. That as long as this MRP, the revenue they generate, is greater than the MRC, what we have to pay them, that's a good thing because they're making us more money than what we have to pay them. If MRC exceeds the MRP, you don't need to hire them because then you're going to pay them more than what they actually generate for the business. So, for perfect competition in the labor market, you've got downward sloping MRP, which is your demand curve, and then perfectly elastic or horizontal MRC. So we're going to pay every worker the same wage. And so just like Mr. Dart, there was one price. Now MRC, there's one wage. And then you have downward sloping marginal revenue product because workers get less efficient over time. That as you hire more workers, eventually there's not going to be enough for them to do, and you're going to see a decrease in that productivity. And so that's why you have that downward sloping MRP, which we refer to as demand. So, up top, you have the cost curves for a perfectly competitive product market. We know marginal cost is your Nike swoosh check mark. It goes down and goes back up. It is actually a mirror image of marginal product based on those first couple workers you hired get more efficient because they specialize, and eventually you see that decrease in productivity, which is the reason marginal cost goes down and then it goes back up. And so we know where MR equals MC, that's where that product market, that firm, is going to produce because that's where they're going to maximize profits. Well, at the same time, MRP is essentially a mirror image of marginal cost because these first couple workers, as they get more efficient, and this is really the same thing as marginal product, but now we're just multiplying it times the revenue they generate. But first couple workers are going to get more efficient, and then as you hire more workers, they're going to get less efficient. And so you're going to see MRP actually increase and then decrease. But this tells us right there the quantity of workers they're going to hire for this firm, because anything past that, a greater quantity, that MRC is going to exceed MRP, meaning we have to pay them more than the money they actually make us, which is not good for a business. So, you own a business in the perfectly competitive product market, selling your products at $10 a piece. When you hire workers, you have to pay them $15. So you sell the product for $10, you have to pay your workers $15. We're going to figure out how many workers you should hire based on this MRC, MRP concept. So, number of workers on the left, total product on the right. So remember, total product is the total overall amount being produced. Care about that. Marginal product, remember, is the change in total products. This tells us how many additional units each new worker can make. If we're producing pizzas, one worker can produce 7 pizzas on their own. We hired the second worker together, they can make 17, but the marginal product of that second worker was 10. They were able to produce an additional 10 units when they came on board. Hire a third worker, they produce an additional 7, brings total product 24. This should be real familiar. You've done all this plenty of times by now. Should have. So, the product price is $10, which we know is essentially your marginal cost, but we're going to still call it price here. Marginal revenue product. And this is where we introduce some new calculations. So, first worker can produce 7 pizzas on their own. Well, if we sell those 7 pizzas for $10 a piece, that first worker generated $70 for this business. We hire a second worker. They were able to produce an additional 10 pizzas as their marginal product. Well, we take those 10 pizzas, sell them for $10 a piece. The second worker generated an additional $100 for the business. That's where I'm getting these numbers. It is the price of the product multiplied times the marginal product. And so however many additional units that worker helped produce times the price of the product gives you the marginal revenue product. How much additional revenue that new worker generated for that business. If we add in our marginal resource cost of what we have to pay the worker, this is your marginal analysis. So we pay them $15, they made us $70, that's good. Pay them $15, they made you $100, that's good. You pay them $15, they made you $70, you get the point. You go down, down, down. All right, when you get to this sixth worker, you had to pay them $15, but they only made you $10. They lost you money. You don't need to hire that worker. So, based on this, you would hire 5 workers because that is the last employee that generated more money for the business than what you have to pay them. Anything past that, you're wasting money because they're not a good employee.
So they're making that many an hour?
Don't ever think it. Don't ever think it. Just concept. Marginal analysis. So, side-by-side graphs. You've got the market on the left, you've got the firm on the right. We know it's a wage-taking firm, so whatever that equilibrium wage in the market is, the firm is also going to accept that to pay their employees. Downward sloping demand, so we know the firm is going to hire workers at QE. An increase in the supply of labor. So for whatever reason, we see new workers enter into this market. Well, it's going to change the equilibrium. So it's going to decrease the equilibrium wage and increase the quantity of workers in the market. Because now, excuse me, if we have this new influx of workers, we have more options of people to hire. Well, we can offer them a lower wage because somebody's going to take it. And so we see a decrease in wage in the market. Well, if this is a wage-taking firm, it's now going to accept the new MRC, which is the wage. We're going to see an increase of workers. So we're actually going to hire workers because now we have to pay them a lower wage, or we can pay them a lower wage. And so we're going to employ more people because it's more cost efficient. So, same things happen as it did in Unit 3 with perfect competition. That whatever happens in that market, the firm's going to accept that new wage, and that's how they're going to set everything up. Alright, this is the last thing for 5.3. This is utility maximization. We just call it something different. So if we go way back to the end of Unit 1, and you had 2 different activities, you had a set amount of money, and this is when we introduced utils. Remember utils? We talked about utils per dollar spent.
Isn't that really weird Texas difference guy?
Yes, because that's the only thing you'll remember is Jeremy Bonham and his preserved body and head. But
No, not the head. It was sold.
yeah, well, they eventually gave him a prosthetic head. So, but you had two activities. Each had a price. You had a set amount of money. You had to figure out the utility per dollar spent, and then based on that utils per dollar, you went down and spent your money and found those combinations. Remember that? Roughly? I know you probably would need some practice, but remember what I'm talking about? Spending those utils. All right. This is the same thing, but we're looking at quantity of labor to hire. So we have two workers. We have robots and we have humans. Robots cost $10 a piece. Humans, well, I don't want to say cost. We can employ robots for $10. We can employ a human for $5. So, number of units, 1, 2, 3, 4. That's how many. We've got the marginal product. So the marginal product for the first robot is 30. The marginal product for the second robot is 20. Marginal product for the first human is 20. Marginal product for the second human is 15. That's what those numbers mean. That's the change in the total product. So now we have to get the marginal product per dollar spent to employ that worker. But it's the same exact thing. You take whatever this is, divide it by the price, or the wage, to be more specific. That gives you the marginal product per dollar spent with what we have to pay the worker. So, the first human is 4. As far as how many units can they produce based on what we have to pay them. Or essentially, they're producing, if this is pizzas, they're producing 4 pizzas for every $1 we have to pay them. Here, they're only producing 3. But if it tells us that we have $35 to spend, it's the exact same process. You're going to hire this one, then you're going to hire those two, and then you're going to hire these two. And so 10, 20, 25, 30, $35, all your money spent. This is the most productive combination of worker that you can hire for that $35. This combination of 2 robots and 3 humans is going to produce the most products or the most pizzas or whatever. You remember this?
Yes.
So it's the exact same thing as utility maximization that we did like months ago. But instead of figuring out how to generate the most utils per dollar spent with a set amount of money, now you are figuring out how to produce the most products for a set amount of money to hire workers. It's all the exact same thing, we're just changing the terms. But as far as the calculations, it's still the same. Formula is instead of MUX over the price, now it's the marginal product over the price that we have to pay the workers. And so, but it's still that exact same process. And so these two numbers, because of that, are always going to equal out because it's still a budget constraint. I mean, if we wanted to get into all the graphing, we could. I'm not going to today. But essentially, you have a budget line, and this is the tangency on the budget line of where these two numbers equal each other. But if you remember utility maximization, this is the exact same thing. This one doesn't come up near as much. This one's actually kind of rare to show up on the test. It does occasionally, but more commonly, you're going to get utility maximization looking at utils per dollar spent. But if it ever refers to the least cost rule, that's what it's referring to, is how do you've got $35, how do you hire workers to be most efficient, or what's the most efficient combination of workers you can hire for that $35? Questions there?